Rebuilding your PQ200 sampling pump is easy to do and will save you both time and money. Pump motors and diaphragms should be replaced after 9,000 hours of use, while eccentric bearings and valves can be replaced after 14,000 hours of use. To start rebuilding your pump, remove the two screws that secure the motor to the pump body. The motor assembly can now be pulled away from the pump body. Inspect the eccentric bearings for looseness on the shaft. Inspect the bearing for smooth rotation and absence of play. If these components are in good condition, then wipe the bearing clean with a fresh, lint-free cloth and re-lubricate with light grease. Set aside for reassembling. If the bearing requires replacement, loosen the set screw on the eccentric shaft and remove the bearing or eccentric assembly. Replace with a new assembly, pushing it firmly onto the shaft as far as it will go before tightening the set screw. If the motor also requires replacement after removing the eccentric bearing assembly, also remove the 3 motor plate screws which secure the motor plate to the motor. The new motor is attached to the plate utilizing the 3 screws just removed. Before beginning valve disassembly, it is important to note that if improperly assembled, the pump will malfunction and little to no air will be pumped. MESA suggests drawing a line or witness mark across the entire face of the pump body. Doing this will make it very difficult to commit a misalignment error if the marks are exactly aligned during reassembly. Do not draw lines on the face containing the motor nor the mounting studs. Starting on either side of the pump, remove 4 screws from the valve upper plate, lift off and set aside. The valve plate alignment pins are pressed into the plate. Do not attempt to remove them. Carefully remove the valve, which may be lightly adhered to the upper or lower plate. Be extremely careful, as this component is very thin. Set aside for inspection. Next, remove the valve lower plate. This component is usually a tight fit and a tool may be required to separate. Set aside, taking care to remove and retain the 4 O-rings. Repeat the same procedure on the other side of the pump. All visible metal parts should be bright and clean, completely free of corrosion or dirt. The leaves of the valve should be nearly flat or only slightly curved and should be free of chips or cracks. If the valves are not perfect, they should be replaced. If they are dirty, they should be carefully wiped clean with a fresh, lint-free cloth. The diaphragms are removed by grasping the diaphragm retainer between the thumb and forefinger and rotating in a counterclockwise direction while looking down at it. The other hand is used to grasp the same component on the opposite side. In this manner, one of the retainers may be removed. The remaining retainer is removed by inserting a finger through the bearing hole and forcing the yoke against an inside wall. Set these components aside for inspection. To inspect the condition of a diaphragm, grasp it across its diameter and pull in opposite directions. If any cracks in the surface are observed, the diaphragm must be discarded. If a new or used diaphragm is being installed, insert the retainer into the diaphragm and slide the retainer bushing over the diaphragm retainer shaft. Align the threaded hole in the yoke such that the diaphragm assembly may be inserted through its guide hole in the pump body and screwed into the yoke. Seize the follower yoke with a pair of long nose pliers and insert it through the drive hole in the pump housing. Grasp the diaphragm retainer between the thumb and forefinger and rotate clockwise 2 turns. The diaphragm will be lying on top of the pump body. Leave it that way for the moment. Prepare the opposite diaphragm assembly and screw it into the yoke, holding each assembly between the thumb and forefinger of each hand. Looking through the drive hole, align the yoke by eye so that you are looking into the bearing drive recess and align it such that it will receive the eccentric bearing and is parallel to the pump sides and square to the face. Now complete tightening the loose diaphragm retainers to the yoke and check alignment. Each diaphragm may now be inserted into its respective recess. The edges of the discs are to be tucked into the recess in the pump body. Now, install the 8 O-rings into the body and set the assembly aside. Lay the valve upper plate face down on the work surface. Lay the valve plate onto the face of the pump using the guide pins for alignment. If it is a used valve and the leaves have curved, be certain that the curve is toward the round holes in the valve plate. Lay the flat surface of the valve plate on top of the valve using the guide pin holes for alignment. Press it home into the diaphragm recess and align the witness marks on the valve plates with those on the body. Install the 4 securing screws, but do not fully tighten yet. Assemble and install the other valve components to the body in the same manner. All 8 of the valve plate screws may now be tightened. Place the motor assembly into the hole in the pump body and rotate it until the bearing engages the opening in the yoke. The motor plate will not lie flat to the body unless the bearing is engaged in the yoke. Once this is accomplished, align the 2 screw holes in the motor plate to the screw holes in the pump body. Reinstall the 2 motor plate screws. Before fully tightening the screws, centralize the motor plate on the pump body. Recalibration of a PQ100 or PQ200 is not required after the rebuilding of a pump, but in following good practice, it is always wise to verify flow calibration after replacing a major component. Your pump can now be reinstalled in the instrument. For detailed, step-by-step instructions on how to complete a pump rebuild and what procedures to follow after reinstalling the pump in your sampler, visit our website at bgi.mesalabs.com.